Welcome to the Crazy Hat Chemist. So here we go again today, the 17th video, a density problem on the unit of scientific measurements. So let's get started. Bam! A density problem. So determine the density of a garnet given the following data. So an empty 25 ml graduated cylinder has a mass of 32.54 grams. The same graduated cylinder, when filled with 13.0 milliliters of an aqueous liquid, has a mass of 45.36 grams. When the garnet is placed in the graduated cylinder containing the aqueous liquid, a new volume of 13.8 milliliters and the combined mass of 48.53 grams is obtained. So what I want you to do is pause the video and I want you to draw diagrams of all three situations and then restart that video. So here we go, restarting that video with your diagrams already drawn. So there is a picture of a garnet if you're just wondering what is a garnet. Okay. And so here we go. This is the graduated cylinder, okay, empty, 32.54 grams. That's our cylinder. Then, here's our graduated cylinder with an aqueous liquid in it, and that's 45.36 grams. Okay, so this is the cylinder and the liquid, and it has a volume of 13 milliliters. Excellent. All right, fantastic. So our third situation is the following. We have 48.53 grams of the garnet inside the aqueous solution. So this is the cylinder, the liquid, and the garnet combined. And you can see the volume on that, and that is 13.8 milliliters. So the question is, we're trying to get the density of the garnet. So which two situations are we going to be using? Are we going to be using the empty graduated cylinder? Are we going to be using the graduated cylinder with the aqueous liquid? Or are we going to be using the graduated cylinder with the liquid and the garnet in it? Again, remember, we're trying to solve for the density of the garnet. So we need to get the mass of the garnet per unit volume of the garnet. So I want you to circle the two situations in which you are using to determine the density of the garnet. All right, there they are. Those are the two situations in which we are using. So we are not using the empty graduated cylinder by itself. We are using the graduated cylinder with the aqueous solution in it, and we are using the graduated cylinder solution, aqueous solution, and the garnet. And what we're going to do is we're going to get the mass of the garnet from the difference in masses. Then we're going to get the volume of the garnet from the difference in volumes. This is a volume displacement method. Okay? Hopefully that makes sense for you. All right, so let's do the math on this problem. Refer back to this slide right here so that you know exactly where the numbers are coming from. So let's keep on going. So density is, we're trying to get the garnet. So the density of the garnet is equal to the mass of the garnet divided by the volume of the garnet. So we're going to get the mass of the garnet, then we're going to get the volume of the garnet, and then we're going to divide those two numbers. So this is how we obtain the mass of the garnet. We take the 48.53 grams minus the 45.36 grams. So the 48.53 grams is the garnet, the cylinder, and the aqueous solution, all three combined. The 45.36 grams is the solution, the aqueous solution, and the cylinder. And then we take the difference of those two, and that will give me the mass of the garnet. So the mass of the garnet is 3.17 grams. I've used a correct number of decimal places, which is 2. Okay? All right, now we need to get the volume of the garnet. So here's the volume of the garnet. We're going to take the 13.0 milliliters, that is the aqueous liquid, minus the 13.8 milliliters, that is the aqueous liquid, plus the garnet. We're going to take the difference of those two, and we are using decimal places again in the 10th position. So the volume, 0.8 milliliters, is actually the volume of the garnet. So now I have the mass of the garnet, 3.17 grams, and the volume of the garnet, 0.8 grams. Sorry, 0.8 milliliters. Thank you. And we're going to divide those two. So we're going to place those right there. And now we're going to look at the number of significant figures that we have after we do the division of this problem. This is what comes out of the calculator that I get. I haven't rounded yet. But I need to look at the numerator and how many significant figures are there? 3. The denominator, how many significant figures are there? 1. So those are my significant figures. So when I'm doing a division or a multiplication problem, I'm using the fewest number of significant figures. So I need to round the 3.9625 to one significant figure, and I need to include units on that. And that is right here. So that will be 4 grams per milliliter is the density of the garnet. Hopefully that problem worked out for you. Okay, redo that problem. Make sure that you can do those drawings. I can't emphasize enough how important it is to draw diagrams of chemistry problems. Students should be wearing safety goggles at all times. However, in the event of an emergency, students should do the following. Press on the foot pedal or push back on the handle. Hold the eyelids back. Wash eyes for 15 minutes. Then contact emergency provider to have your eyes checked out by your healthcare provider. So remember to always wear your goggles when in a lab. That is essential. I am the Crazy Hat Chemist. I hope you had a great time on this video. Give me a thumbs up, subscribe to my channel, and I'll see you next time for the next video.